Hello everyone, and welcome to another episode of the Trade Sailor Project. In this episode, we're going to do the second part of the second iteration. So let's go! So this week we're back at the boring PowerPoint presentation again. Sorry, but this is just the best way to show these the data. What we're going to do is the evaluation of the second iteration. Actually, the evaluation of the whole iteration, including the work I did on the second iteration. So let's go. So like I said, we're going to do the whole iteration. I'm going to go pretty quickly through the first 5 points. And then we start at construction and work our way up to evaluation, which we're doing with this presentation. But first the comments. So first comment is from Simon Crook. He says, a very nice Jägertron. Thanks very much, Simon. Always like nice comments. From Pete. Looks good. I imagine the sails would need to be tough. Yes, they would be. Easy and quick to set and adjust. Maybe an industrial style furling boom, where the whole boom spins with a winch. So I don't want to spin the whole boom, but I might my idea was to put a furling boom in, because I like the furling boom system. And it will be spun around either electric or manual. But manual might be a bit big. So it might be an electric system. So yes, that's the good idea, Pete. Thanks. And from Michelle, well done, Katran. I found this video a joy to watch. I love being able to see where the stairs are and where the guests and crew will sleep, etc. Yes, the interior we're going to have a bit more chat about today. The last part was lovely and colorful and clear. It will be a real beauty to behold out in the open ocean. Just need someone to build it. Another thing we're going to discuss. So yes, let's keep going with the next step. So a bit of a recap from last week. So this is the hull and the deck design. Already put the keel and the rudders in just to give it a bit more clarity. But yeah, so I've faired the hull to make it buildable, and we fixed the bow shape and moved the center of buoyancy a little bit. Then a keel, rudder, sail, and rig. I've plotted them in here. So I've had a chat with a friend of mine, Melle, and he suggested to have freestanding masts, so the rigging was less of a damage to get damaged when loading and unloading the containers or other cargo. Yeah, that's something I thought about as well. I'm just only thing I'm a bit not sure about is the price. So if anybody's got an idea about price difference between the freestanding masts and old-fashioned state masts, let me know. The furling boom, thanks Pete. And I might add a bowsprit for a big Jenniker, so a big downwind sail on it. So this is the general arrangement, as we discussed it already as well. Things I still want to do in the next iteration is styling the deck house a little bit more, the styling of the transom maybe. Also a point from Melle. Interior layout options. I want to add a few different options for the interior layout. So it says luxury guests. Maybe if they want to run with tourists on board, could be an extra business idea. If you have an idea about the interior layout, please let me know in the comments of this video. And some debits maybe for the rescue boat. So that was it for it, but I'm pretty happy with the layout as it is. So for the construction, I've recalculated the deck house for steel, yes, another thing I found out when I did the stability calculations and the ballast modification. So I've been playing with the ballast water amount to see how little I could get away with, and I can actually remove the wing tanks, so which will help me to reduce the steel weight even further, also the building cost. And we might be able to remove the cargo hold sidewalls, so the containers will have guides to be guided down, but there won't be any sidewalls anymore in the cargo hatch, which allows us to carry more bulk goods and easier inspect Okay, so here's the work I did on the resistance and power. So I ran the power calculations again. Because we've got a little bit lighter and a little bit less beam, we need a little bit less power now. I can actually get 10 knots with 250 kilowatts instead of the 300 we had before. With 320, which I can get the motors for, we will do between 10.5 and 11.5 knots, depending on the loading condition. The range has not changed that much. A little bit less because we need less resistance. And I've added the downwind sail. So for this iteration, I put a spinnaker in, and it massively increased the downwind speed, of course. The question is, if you want a boat like this, want to run a spinnaker, but probably a Jenniker on a roller furler could be a very good idea, or a really big jib for downwind. So the weights and moments, I've done a modification of the deck house into steel. And we increased the accommodation weight because we got more accommodation now. Also, the deck house and the added raise of the aft deck have been included, and I've overall modified the new geometry in the steel weight. So that's has caused a slight change of the lightship weight. It's gotten a little bit heavier. And that gets us to hydrostatics and stability. So as you can see, I've added the deck house and the raised aft deck in the 3D model for stability calculations. On the right, you can see in the green pictures the 3 different trim conditions, with light load very much trim, but half load and full load still slightly bowed down, which I will need to address in the next iteration. I might move the water tanks aft a little bit. And also move, add another ballast tank at the front so we can trim a bit more effectively. And we've got the GZ curve. As you can see, there's now a second hump in the GZ curve. That's where the superstructure hits the water, which will need to be weather tight for this to be able to allow this in. But as you can see, the point of vanishing stability, so where the GZ curve goes through the 0 line, has increased massively. That was first 90, and now we're at about 170, 160 degrees, where also the bit under the curve has gotten a lot smaller. It was very similar to the top bit, and now it's almost non-existent, which means that if the boat goes upside down, it's very likely to right itself again. So that's a very important safety feature. Yeah, so that's I'm very happy with the change, and that's due to the decreasing of the beam and the lowering of the keel, which helps massively with the stability. As I can see for the other loading conditions, because this is the GZ curve for the full load condition, the half load and the light load are even higher GZ. So it's this is the worst loading condition, which is logical because the container weight pulls the weight up. All right, so that was stability and hydrostatics. And that was the end of the evaluation of the second iteration of concept design. And I think we've got a pretty strong concept now. We've got a good idea of what does what. Still a few little tweaks, but we can do that in the next stage. So next week I want to start basic design. And what that means is that I'm going to do a whole heap of drawings, basically to get the design ready for a shipyard to put a price on it. Yeah, so that's the next step, basic design. All right. I hope to see you next week. I hope you enjoyed this video. Feel free to like and definitely share this video with friends or people you might be think might be interested. And hope to see you next week. Okay, bye-bye.